In this question, you are given a ball that's moving downwards with an initial velocity greater than the terminal velocity. Now, let's start with what is terminal velocity. That's basically the maximum constant speed or constant velocity which the object can achieve while falling through a fluid, maybe air or liquid. But in this case, the question is talking about air. And when that happens, that means to say that the object, the gravitational force that's acting downwards on the object is equals to the upward drag force, or we call it the air resistance due to air resistance. Both are equal. So basically that's your Newton's first law. The net force acting on the ball is zero, the acceleration is zero, so it falls at constant speed. Now this question can be a bit confusing because students are used to the speed time curve where when there's terminal velocity, you release the object, eventually you reach terminal velocity, but this is different. They say that the initial velocity is actually higher, greater than the terminal velocity. So in other words, the graph will actually looks like, let's assume the initial is here, then it will reach terminal velocity. So what kind of scenarios is possible to achieve this kind of speed time graph? Now I'll give you some examples here, possible scenarios. For example, an object that is falling through vacuum, and it may be a meteor or a space capsule that's entering into the Earth atmosphere. This is the Earth, this is the atmosphere, and if it's traveling at very high speed, that means the initial velocity is very high. Once it enters into the atmosphere, because there's air drag due to air resistance, so you will slow down and eventually it will reach terminal velocity. That's one possibility. Another possibility is like you are throwing an object down from, let's say, from an aircraft. You throw it vertically down because you give it an initial thrust. The speed initially is very high, and then due to air resistance, all right, eventually you will reach terminal velocity. That's one possibility. Or you basically fires a gun downwards towards the Earth from, let's say, a very high up in the sky, okay, from an aircraft. Or another one that you may be very familiar with is when the moment you activate, just when you activate the parachute, okay, so right now the air resistance will be very large and the weight is still the same, and the speed here initially will be higher, and then because of the air resistance is greater than the weight, you start to decelerate and you will slow down, and eventually you'll glide down at terminal velocity. All right, and lastly, it may be, but in this case this is a liquid. Okay, so if a stone you drop from very high ground, when it enters into the water, the speed here is higher, then it will slow down and eventually reach terminal velocity in the water. So these are some possibility of scenarios where the so-called the initial velocity is greater than the terminal velocity. Now let's go back to the question, and maybe let's start from D. All right, D, it has an acceleration that is equal to the acceleration, but acceleration of free fall. You know, free fall is 10 meters per second square, but because the fact that it has air resistance, once you have air resistance, okay, the net force is definitely smaller, and the net force downward is smaller, so the acceleration will definitely be less than 10 meters per second square acceleration due to free fall. So D is wrong. The terminal velocity of the ball increases. Well, for this case, the terminal velocity actually depends on the property of the object and the fluid, in this case the air. It does not increase due to the initial velocity. So no matter how hard you throw a ball down with a speed, initial speed that's higher, eventually it's going through air, it will reach terminal velocity when the air drag, the air resistance, is equal and opposite to the weight. All right, so it's not, the terminal velocity will not increase. So C is wrong. How about B? It continues to descend at initial velocity, so it will not continue to move at that speed. If that's the case, that will be just constant speed and the graph will look like that, which is not the case. So B is wrong also. So now let's go to, so the answer will be A, it begins to slow down. So as mentioned just now, all the possible scenarios. So it's like when the object, okay, is falling downwards towards the earth and the weight is there, and this at this time where the air resistance is actually greater than the weight, so the net force, which is your air resistance minus the weight, is upwards, which is opposite to the motion of the falling object. That's why it causes it to decelerate, the speed will decrease, and eventually it reaches the terminal velocity when the weight, because it's slowing down, the air resistance will reduce until the weight is equal and opposite to the air resistance. Net force is 0, so from then onwards you'll fall at a constant speed, terminal velocity. I hope you understand the question now. Thank you.